Thanks, David. Good morning, y'all. Um, so before I start, I just want to acknowledge the people behind this work, whatever I do. Okay. So Alejandra Monterosa, she was master's student. She's basically generated all the data that I'm going to present today. Matthew helped me with tissue samples and to positively identify the virus in the samples. Ron, we just heard Ron, and so he's basically helped me to ID the mind itself. Okay, that's how it works. And Andrew works for. So by the way, my name is Shimat Joseph, and I'm located in Griffin campus in Georgia and with the University of Georgia. So I'm not a night guy. That's it. Some people are saying, but I work with might. I'm interested in this system. Is very interesting. Provided there is money, that's another thing because it's a very dedicated work and needs somebody that needs to look at very carefully. Anyway, just to start with, I started my job in 2017 in Georgia. And one so good thing that happened is Jean Woodward. And she was so gracious enough that she took me to some of the nurseries. And I happened to be certain nurseries that had issues with this problem, issues with this particular most was the disease. So this picture is coming from that nursery. It's a trip I had with Jean back then, and seems like the grower, has to throw off a lot of pots the previous year because he found disease here in the collection, and that's basically driving us to work on this issue. So Georgia is not number one or number two. It's still it's significant, in terms of production. So it is important to have a program on this. So this is kind of a pictures that I took that time when we see symptoms, and it was verified by Jane as so in Georgia, it is not updated. It's basically coming from Joe's website. Is I so so the point I want to make here is most of our stuff going on in Georgia is around Atlanta at this point, and looks like that's a place where people are planting roses, and if you go south, there is no rose. Maybe probably people are not planting. That's my guess. There is no rose around there unless there is some gardens and you might have seen. But there are native roses. We know that as you drive on the state line roads, we see on the hedges there's a lot of roses there. So it's not like it's not there. It's there. It's wild rose. Most probably it's going to be roses or cherries. I'm not sure, but it's there. Okay, but we rarely see the disease there in that scenario. So most of the things that you see around Atlanta is knockout roses where the landscapers are planting in the people's yard. Okay, this general life cycle of the night. I mean, I am ashamed because we have a specialist talking about this right before this talk. Anyway, this is what the female goes through egg-laying and goes through two immature stages before started. It's very simple and can happen as quick as 7 days. And it's a haplodiploid. The females basically lays most eggs and lay 1 egg per day. Females can live up to about 2 weeks. And you can see the male and female are very different. It's a picture you already saw. As I thought it's very captivating picture too. And I can't resist not to show. I know you might have seen that from yesterday's talks too as well. This is from Gary's picture. And you can clearly see the eggs there, and the spermatophore that's all there, and the trichome, and in the jungle, basically. In the jungle that's created for this minds to live. So this is basically the identification characters. We are looking at Phytococcus verticalis. So if you look at the shield and the picture, you can see that shield. The shield has an. That's one. And on the other side, you see the flap, the power flap, and there is some median ridges and there is flat and there is very dotted ridges and those kind of characters as you look at. So it's not something that I can do. Definitely it's by John. John has to work on and try to figure out. So for our samples, time to time we send out to him. And also Austin 5 in Florida Savings Lab also helped me to identify those because when you collect so many and you have seasonal abundance, we're collecting a lot of unifieds. It is impossible to say send everything ID positively to I know Mark did that. Kudos to you. It's very difficult to do it. Okay, practically. So just some of the rationale for this talk, some of the work that's done by Amrine on multi-roses in Indiana, and we don't have much work done in the southeastern region, except what we work in the past. So we're kind of interested to look at that and look at the phenology of which presumably the Phyllocoptes fruticulus. Okay, that's kind of assumption here because we don't know exact every mite that we caught is the same. And we were also interested to understand the relationship on with temperature and also latent heat. So this move on. And if you're interested to read about this work, I'm going to present it and always get this paper. Okay. So this is a picture from our garden in our campus. So they are there. So when I started talking to people, and they're saying there are roses planted in the garden, like in 2009, 2010, that period, and roses started showing these symptoms. So it's there for a while. So it's maybe 7 or 8 years when I came here, we had another batch where you can see there is plots here, and roses was planted for some other reason, not exactly for the roses disease or anything like that, but it started appearing here. And according to people, we came to know that the damage, the disease showed up like 2016 or so. So that's where I started getting into this. So the roses that we work with kind of mixed again. In the garden, we have different varieties and different cultivars. There are prickly roses, red drift roses, and roses, of course. Because when these red drift and prickly roses die with this disease, they're replaced with non-ox. That's what's happening right now. Now they are not planting roses at all. That's reality. Anyway. And those roses were about 3 to 15 years old, so it was there for some time. And they are about tall as like that, something like that. They are irrigated and they are pruned back in the winter time. And usually we don't use any insecticides or any pesticides in this case for management purposes. So, for this studies, what we did is in the beginning when we started tagging the roses that showed symptoms, and the roses were sent to Matthew's lab to make sure there are RRD and the virus in there, and they all came out positive. So what I did was we tagged 4 bushes of symptomatic those roses showing the symptoms from RRD that's already verified with the virus, and also about 10 meters apart there are a group of roses that I kind of call it as a non-symptomatic because we didn't see any symptoms at point when we started the experiment. This work here. And what we did is every 2 weeks interval we collected about 10 meters long terminals. So it includes a flower bud and how long that takes. Maybe there's 2 leaves or something like that with a stem. And that's what we sampled from these plants. So we were interested to see, because when we look at there are flowers that's open, their flowers are closed. So we had to account for that. So we basically sampled 8 samples from those 2 cohorts, symptomatic and non-symptomatic, and brought to the lab. Then basically what we did is we chopped every piece apart and start counting the mites we are finding on this the samples will be collected. So it is opened and closed. We recorded that information, and also each part we are finding needs, we are also counted. And we are only interested in the Eriophytes in this case. Okay, again, Eriophyte syndrome. I'm not saying Phytococcus here in this case. So in the flower, we looked at the stem, the style, the stigma, anthers, and all those structures in the flowers as well. So we just try to tease everything apart. So in 2019 and 20, that's where we did this work. This is just to show the symptomatic and non-symptomatic. You can see that. And clearly, as Mark indicated, that we know that for like a few years now, they like symptomatic plants. And there's no surprise here. That's exactly what we are seeing here. And overall, if you look, most of the mice we're finding is on symptomatic. Between open and closed, are non-symptomatic between 2 years. You can see we didn't see much difference here. Again, if you pay attention to the scale here, we are not finding that many. That's another thing to keep in mind. And if you look at the symptomatic in both years, you look at the numbers, it's pretty high. Yes. And again, there is no difference here. So that's interesting. Whether it is closed or it's open, we are seeing about same numbers. Statistically, they are not different. It's just to show the seasonal average. It's basically the same thing in a different. So we are interested in the flower parts where you're finding it. Again, we are seeing a lot. This is on non-symptomatic for the both years. And you can see there are two structures that we see a lot on sepals and also the base of the leaves. When the leaves and intersect the stem, there is a little bit of trichomes there. That's what we are seeing. And that area, that's what we are seeing. And on other structures, a flower, leaf, like stem or parts of the leaves or whatever, on the upper side of the leaf or lower side of the leaf, we didn't see that many there. And basically, we club everything together. We call it like others. That's what you're seeing there. Okay, so you can see the numbers of the video. So anyway, on the non-symptomatic tissue, we are not seeing that many, but you can still see more separation with regard to the sepals on the base. But if you look at the symptomatic, it's overwhelmingly higher numbers we are seeing, and that's the place where to go. It looks like it. So that's not flower, but samples, sepals. That's what we did. Later on, that's what our sampling was. We didn't look at the flower or terminal samples. We just do the sepals. That's it. That's all we did. Again, to show this seasonal average, you can see that. So again, I just want to make sure when we did this work, we didn't know. Only thing that we know at that point was transmitting this virus was Phytococcus virtualis. Now we know that there are, we just heard that too. There's some other things, developments happening. And this was one paper that was out there when we were about to submit our work. So moving on to another study. Again, this work is also published, so we're in this we can do that. Where we are interested to look at the temperature effects. And that's obviously one question that came up all the time, and that's what we are trying to do. So in this case, what we did is we collected the samples from symptomatic plants. So that's a tissue we are collecting, and we just roughly went through that, and we think is about 20 minutes we reduced onto the plants. So then these plants are in the growth chambers and exposed to different conditions, temperatures. Basically, going to 15.5 degrees from the old, that is about 90 degrees. And you have to put in there it's constant temperature, not fluctuating, constant temperature in the growth chambers. And we sample those and those plants, this knockout plants, that's what we use for this purpose. So 7 days after inoculation, there is some numbers were a little bit higher, but in 90 and that is 80 degrees Fahrenheit, and you can see that. But at the bottom now, you can really see the numbers were really high. So clearly, it's not we know that they respond very well to temperature. So so humidity was kept constant in this case. So we are interested in humidity as well. So in this case, what we did is we took three, very low and very high, and did this work. And the temperature was kept at 80 degrees. So that's the temperature we thought they are doing fairly okay, and these kind of extreme. So this is how it's done. The tissue is collected. The tissues we're collecting is symptomatic tissue from the garden that we have mites. Roughly 20 mites. That's what we just clicked it, put it on the plants, but that's all. And what we are finding here is if you look at the numbers on the cells, so that's what we sampled in this case, and you can see that a lot of mites were seen at 60 RH. So very high or very low numbers didn't shoot up, but kind of just like us, they like kind of the humidity, it seems like. If you look at proportional symptomatic RRD symptoms, we are seeing that the higher the humidity, the better, because the 95% RH showed a lot of symptoms down the lower. Not like it's not there on others, but it's there, but the expression is a lot higher and higher. So just to summarize, so we saw active population of Eriophytes in our garden from May to November. They're abundant more in the symptomatic plants than non-symptomatic plants. And we saw them in both open and closed flower buds. And we saw that they're abundant in the sepal, that's the structure we are seeing. And we also seen that they respond very well to temperature in this case. And relative humidity wise, they like moderate, about 60% relative humidity. And with regard to symptoms, we saw the symptoms more expressing at very high relative humidity. That's all I got. Thank you.